Welcome back. I'm Max Sturs. This is Francis Parento. We have Libby Aldrich on the iPad and Tyler Evangelist sitting there on a pink scooter. We are members of the AP Physics and Multivariable classes here at Holderness School, and this is the second installment to our AP Physics Multivariable projects. What we have decided to do is take another look at Part B and Part C and actually demonstrate what we could do. In Part B, we're trying to determine the rotational inertia from the period. And in Part C, we are actually trying to determine the center of mass.
Alright, so for Part B, so the first example we presented in the previous video was timing the period using just a timer and calculating for 10 oscillations of the pendulum in order to find the period, and after that, in order to find the inertia from the period. So what I'm going to do is I'm just going to calculate 10 oscillations, time it, and then after that we're going to be able to find the period from that. So I'm going to start right now. 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got roughly 13.4 seconds. So if we divide that by 10, we get around 1.3 seconds for the period. And then using 1.3 seconds, we could now find our inertia from that. Now, Max, we'll talk about Part C.
So Part C, we were asked to determine the center of mass, of our pendulum. So we're just going to, take this apart real quickly. And in order to do that, one of the ways we come up with to find the center of mass was we can use the edge of the table as a fulcrum point. And the way you do that is you find it, and I think you have to move it around, figure out where it's going to be, to the point where it's going to settle down and perfectly balance a little bit of this end in the air and have it not actually fall. So I'm going to do a quick demonstration with this before we get into that. Move this down and everything. As you can see, this is roughly hanging in the air without actually falling. And there we would know that the center of mass is at 18 inches, and ironically enough, it is 36 inches, so that works. Now we are actually going to find the center of mass of this thing. So as you know, we had decided to tape down a 100 gram weight to this block to make the center of mass a little, change it, because it's not near the original center of mass, it's not near the pivot point. Therefore, it's substantially changing the center of mass. We have found it. Now we're going to use our meter stick to actually determine where that point actually is. That point is now roughly at around 35.4 centimeters. That's how we have the ability to find the center of mass using simple stuff such as this, and being able to find the period, the rotational inertia of our pendulum using something as simple as a few equations and a phone, which